Module 1, Objective 7, explain how atomic properties influence reactivity and be able to differentiate between covalent, ionic, and hydrogen bond types, generalizing how atoms bond to form molecules and compounds. Electrons and energy levels. Electrons in the electron cloud determine the reactivity of an atom. Remember that electrons orbit the nucleus of an atom within the electron cloud. The electron cloud contains shells, so you have various levels of shells surrounding the nucleus of the atom. We find that these shells, or energy levels, contain a maximum number of electrons, and we always find that the lower shells, the ones that are closest to the nucleus, always fill first. The outermost shell is the valence shell, and it's the valence shell that ultimately determines bonding. Here we have two examples of atoms. The first one is lithium. Lithium has an atomic number of 3. Recall that atomic number refers to the number of protons within the nucleus, but also accounts for the number of electrons if the atom is electrically stable. So in the case of lithium, we have atomic number of 3, we have 3 protons in the nucleus, and 3 electrons in the electron shell, or cloud. Those 3 electrons occupy 2 energy levels. The first energy level can only contain 2. So energy level 1, we'll say first, can only hold 2 electrons. Once that shell is filled, the second and third can hold a maximum of 8 electrons. In the case of neon, neon has an atomic number of 10. We see that the first energy level houses 2 electrons, while the second energy level is going to carry 8. Chemical bonds form molecules and compounds. Molecules occur when 2 or more atoms join by strong bonds. An example of a molecule would be hydrogen. 2 hydrogen atoms bonded together to form a molecule. Compounds contain 2 or more atoms of different elements, joined by either strong or weak bonds. A good example of a molecule would be water. Water contains 2 hydrogen atoms and 1 oxygen. So water is both a molecule as well as a compound. It's a molecule because it has 2 or more atoms joined by strong bonds, and it's a compound because it has 2 or more atoms of different elements, in this case hydrogen and oxygen. Not all molecules are compounds, and not all compounds consist of molecules. Chemical bonding involves the sharing, gaining, and losing of electrons, and there are 3 major types of chemical bonds discussed in this course. We have ionic bonds, covalent bonds, and hydrogen bonds. Ionic bonds form when ions exist. Ion are atoms with an electric charge. In the case of an ionic bond, one atom, known as the electron donor, loses 1 or more electrons and becomes a positively charged cation. Another atom, the electron acceptor, will gain those same electrons, becoming negatively charged, or an anion. Ionic bonds are the attractions between the positively charged cation and the negatively charged anion. We know that opposites attract, and it's the electrical attraction between these 2 ions that ultimately form the ionic bonds. Here's an example of how ionic bonds form. Our first atom is an atom of sodium, and if we sit down and count the number of electrons in an electrically stable sodium atom, we have 2 electrons in the first energy level. We have 8 electrons in the second, and the third energy level has 1. Sodium is going to naturally lose this 1 electron. And if chloride is present, chloride will be the electron acceptor. It will actually take the electron from sodium to fill its outermost shell. Sodium, if we were to count the number of electrons it has, we see that there are 2 in the first energy level, 8 in the second energy level, and 7 in the third. In the case of sodium chloride, the sodium again donates 1 electron in its outermost shell. In doing so, it becomes a cation. Just a quick check of your math. We have 11 protons and now only 10 electrons. So that gives you a positive 1 cation, and that's reflected right here with this positive symbol. Chloride, on the other hand, has a total of 17 electrons originally, but by gaining the 1 electron from sodium, it now has a total of 18. So it has 17 protons in its nucleus, 18 electrons in its cloud, which gives chloride a -1 charge, and it becomes an anion. So again, the ionic bond is the attraction between the positively charged cation and the negatively charged anion, and a bond forms, the ionic bond. Covalent bonds are the strongest of the bond types discussed. They're strong bonds that involve the sharing of electrons. 1 electron is donated by each atom to make a pair of electrons. Sharing 1 pair of electrons creates a single covalent bond, but atoms can also share 2 or even 3 pairs of electrons, giving rise to double covalent bonds or even triple covalent bonds. Here are some examples of covalent bonds. In the case of hydrogen, hydrogen has an atomic number of 1, so there is 1 proton in the nucleus, 1 electron orbiting, and when 2 hydrogen atoms form a covalent bond, they ultimately share their 1 electron, forming a single covalent bond. Oxygen, on the other hand, creates a double covalent bond. They share 2 pairs of electrons. Carbon dioxide is going to form 2 double covalent bonds, seen right here. And we even have an example of nitrogen. When 2 nitrogen atoms bond together covalently, they share 3 pairs of electrons, forming a triple covalent bond. So these are all examples of covalent bonds. The last type of bond discussed are hydrogen bonds. Hydrogen bonds are weak polar bonds between adjacent molecules. So here's the first distinction. The previous 2 bond types discussed involved bonding between atoms. In the case of hydrogen bonding, you have a bonding between molecules. And it's based on, again, that the electrical attraction. Hydrogen bonding involves attraction between the slight positive charge of one end of a molecule to the slight negative charge of a neighboring molecule. A good example of an atom, rather a molecule that forms hydrogen bonds, would be water. And the way that this hydrogen bond forms, if you consider the water molecule, you have an oxygen bonded to two hydrogen atoms. This end of the water molecule is slightly positive. The main reason, as the electrons orbit between these two atoms, the oxygen and the hydrogen, they tend to hang out at this end of the molecule due to the strong positive charge within the nucleus of the oxygen. Oxygen has an atomic number of 8, so there are 8 protons inside of the atom, the nucleus of the oxygen atom, and that's going to attract the electrons to this side of the molecule more frequently. And in doing so, it creates a partial negative charge. The symbolism here refers to partial. So a slight or partial negative charge at this end of the molecule, leaving a partial positive charge at this end of the molecule. If you have another adjacent water molecule with the same type of partial charging, with a partial positive charge at this end of the molecule and a partial negative charge at this end of the molecule, the hydrogen bond forms, and I'll change my color here so it's a little more noticeable. It forms between the partially positive end of this molecule and the partially negative end of its neighboring molecule. Matter exists in 3 main states. Solids contain a constant volume and shape. Liquids contain a volume but changes shape, and gases find that you have changes in both volume and shape.